I'm sure you found lots of things wrong with my code. That's what usually happens to me when I come back to some code I've written some time ago and I have a look at it and really, what the hell was I thinking? Maybe it wasn't quite that bad, but I'm sure there are a couple of things that need to be fixed. We unfortunately don't have time to go into a lot of detail on that, so instead I'm going to talk about three different things. I'm going to talk about something that could be improved in terms of the structure of the code, in terms of the implementation of the code, and then something that I haven't implemented in this code, but that, in my opinion, is pretty important in practice. And that if you really wanted to use this, in particular, if you want to 3D print mazes with this, is something that you would definitely want to have a look at. For all of these, I'm not going to tell you how to solve it because, well, in some cases, I am not entirely sure myself. You're more than welcome to tackle this on your own. You have the code. Take it with you and you can work on that. You can improve your programming skills. Maybe that's something you even want to develop into something that you can do in the classroom, that you can stretch out over a couple of weeks or maybe even a couple of months, where the students start with something very simple and basic and build it up, build it up, build it up into something that's quite complex in the end, just like the maze generator we've been doing here. Okay, let's dive in and have a look at how things could be improved. Here's the code. Again, I unfortunately can't show you everything. You have the entire code in your supplemental material. And the first thing that struck me about this, looking at it a little bit further, is that this bit here, which creates the openings and checks that there's no overlap and that we can reach everything, is very similar to this down here, which does the same thing for the blocks. You can even just see this visually. If I scroll very quickly from up here to down here, you can see that the kind of nesting and the structure overall is really quite similar. There are some differences, and this is the reason why I've implemented it in this way as separate code blocks, because here we need to check whether we have these reachable angles, and then we have these different conditions here, and we need to check whether block angles is defined, which we're not really doing down here. We're doing some additional stuff. We're creating these reachable angles, but the overall structure, in particular, if we only concentrate on checking for overlap, is really very similar. So something you could do if you wanted to improve the structure of this code, to refactor it, in other words, is to try to pull this out into a function to extract this common functionality in a way that you don't have to write the same code twice, but rather that you could reuse a function with different parameters, or maybe it needs to go a little bit further than a function and you need something more sophisticated, maybe a bunch of different interacting functions, but certainly something to reduce this duplication of code here, which is always a good thing. We've talked about this before. If you find that you're writing the same thing or a very similar thing several times, try to pull this out into a function. It will make your code much easier to understand and much easier to maintain later on as well. Okay, so that's one thing that you might want to tackle, and I know that refactoring code is not necessarily the most exciting thing to do because you're not implementing anything new, you're just making sure that it is better maintainable, essentially. But it's really, really important in practice, and it's a good thing to practice. Okay, what's the other thing? Well, if you have played around with this, so let me just run this and rendering. Please wait. There we go. Okay, rendering. Please wait. Okay, still waiting. Still waiting. This sometimes takes a long time, right? It doesn't seem like it should because it's really not all that difficult a problem. But sometimes it's just sitting there like it's doing now and it's saying, please wait. And the wheel is spinning and the wheel is spinning. By the way, if that happens, you can just press Shift Enter again and you will essentially tell it to restart. Of course, it might still take some time. It might still take some time. Oh, there we go. Okay, got lucky this time. So what's going on here? This is obviously something that we don't really want in practice because we don't want to wait a long time for this to be done. This is still a relatively small example. 5 concentric rings. If we're doing more, which we might reasonably want to do, and then 3D print something larger. This might take even longer. What's going on here? So the problem is really, again, this code here that we've just talked about refactoring. What are we doing here? And also down here where we're generating the blocks. We're generating a random number, the angle for the block or the opening, and then we check all kinds of conditions to see whether this is satisfactory. If it's not satisfactory, we're simply saying, well, okay, that didn't work. Let's try this again, and we generate another random number. Whether we get something that's better or worse is entirely up to chance. So if we get lucky, this might work really well. If we don't get lucky, we might be generating a lot of random numbers before we get something that's acceptable. And this happens many, many times because we're doing this for every opening and for every block at every level. In particular, as we increase the size, maybe we want to have 10 concentric rings instead of just 5. This might take much, much longer. Now, the thing about this is that we don't really need to do it this way, because if we check, for example, for overlap, as we're doing here, and we do find that there is overlap, we don't need to generate a random number. We can fix this, right? We can say, oh, okay, this overlaps with this particular opening, this block overlaps with this particular opening, so let me just add another 5 degrees or something like that to it, something reasonably small that will now make sure that there is no overlap. Similarly, up here, where we're creating the openings, we could just create these openings within one of the segments of the reachable angles, and similarly, if there is overlap, adjust it instead of generating a random number. This would be much better in practice. This would run much faster in practice because we're not relying on pure luck to get something that works. It would also be more difficult to implement because I would need to check when I'm adding something or subtracting something from an angle to avoid an overlap, whether this is now overlapping with something else, or maybe it's now outside the reachable angle. So the structure of the code and the logic behind it would get much more complex. That's the reason I haven't done this here. If you want to have a go at this, you're more than welcome. And in particular, this is something that is also important in practice because, as we have already seen, this can sometimes take a long time, and really, there's no reason that it should. Okay, so this brings me to the final thing, and this is something in addition that I would want to implement, in particular with respect to 3D printing. Let me just point out this bit here. In terms of the maze itself, this is fine. If I wanted to 3D print this bit isn't connected to anything else. So this will fall out unless I print some kind of bottom below it or something on top of it as well. But again, it doesn't actually need to be that way. We could now introduce a third condition for openings and for blocks to be acceptable. In addition to no overlap and being reachable from the outside, we also want to make sure that these disconnected things here don't happen. And you could do that in a very similar fashion to how we have implemented the reachable angles by having something that's, for example, called connected angles. And that essentially keeps track of the outside ring and the blocks that have been added to connect it to the next ring. These blocks obviously occur at specific angles, and that together with the openings at the next level tells us what part of this ring is actually connected. So this we can, as a third condition, use to check whether particular openings and particular blocks are acceptable, and then make sure that we can 3D print this entire thing without bits falling off. The example that I showed you that I 3D printed, it actually took me a couple of tries and a couple of times generating a maze before I found something that I could 3D print without then bits and pieces falling out. Because this actually happens quite often. You can see one here, but there's another one here. And less obviously, there's this bit here, which is connected to the inner ring, but then it's not connected to anything else. So this would also fall out if I just 3D printed it. So somewhat complex thing to check, but we can fortunately do this in a similar fashion to before. Again, I haven't implemented this here just to keep the code reasonably short and not too complex, but this is certainly something that you can now do on your own now that you've practiced everything that's necessary to do this. And that would add a lot of value in practice, because instead of having to generate a lot of random mazes until you find one that works, you would just generate it and you could 3D print it straight away. So these are just 3 examples of what could be improved about this particular code and this particular implementation here. I'm sure you found a lot more. Feel free to play around with this. The code is available to you. This website is completely free. You can go and you can play around with this. Have fun.